Exercise question 5.9. A rocket with a lift-off mass 20,000 kg is blasted upward with an initial acceleration of 5 meter per second square. Calculate the initial thrust of the blast. Initial thrust means initial force. So when rocket is placed, suppose this way a rocket is placed here, so the weight of the rocket will be working in the downward direction, perpendicular downward direction, and this is equal to mg, where m is the mass of the rocket and g is the acceleration due to gravity. To provide its initial thrust, a force is required F. A force is required F, so that the resultant of this F and mg will give the acceleration, initial acceleration, that is A, or you can say the ma force will be provided in upward direction, where m is the mass of the rocket, the lift-off mass of the rocket, and A is the initial acceleration provided to the rocket. Okay, so what we find here, actually we find that this force F, what we find here, the force F and mg, this is the initial thrust which is required, and mg is the weight of the rocket. The difference of these two will provide the initial acceleration or initial thrust, that is the ma, will provide ma means the acceleration to the rocket, by what acceleration it is moving initially. Okay, so F is the initial thrust and this is ma, this mg you will take in this direction, this mg is the weight of the rocket, F is the initial thrust, m is the mass of the rocket, a is the initial acceleration produced on the rocket, and g is the acceleration due to gravity which is working downward direction or towards the center. Here m is given to us 20,000 kg, and this acceleration, initial acceleration, is given 5 meter per second square. G you can take 9.8 or you can take 10 meter per second square. I am taking 10 meter per second square for convenience. Okay, now you will see that this is meter per second square. Okay, now F is equal to this 20,000 multiplied by 15 kilogram meter per second square, or you can say simply Newton it is. F is equal to 15 2s are 30, so 30000 Newton, or F is equal to 3 into 10 to the power 5 Newton. So the 3 into 10 to the power 5 Newton is required, that is the initial thrust or initial force required to lift off the mass of, means to lift or to the blast upward direction to the rocket, that is of initial mass, means which is having the initial mass 20,000 kg. Okay, another doubt question. A machine gun of mass 10 kg fires 20 gram bullets at the rate of 10 bullets per second with a speed of 500 meter per second. What force is required to hold the gun in position? It is given mass of gun, suppose m1 is 10 kg, let velocity of gun v1, which is not given here, mass of one bullet is 20 gram, So mass of 10 bullets is 20 into 10, that means 200 gram. Change this into kilograms, so it will be 0.2 kg. Now it is given here the speed of this bullet, 10 bullets, this is equal to 500 meter per second. So speed of the bullet is given here. The speed of bullets given here, that is 500 meter per second. Let it is V2. Okay. Now we know that before firing the gun was in rest position. So according to this, the momentum will be 0. And we know by the law of conservation of momentum, momentum before is equal to momentum after. That means momentum before is 0, so momentum after is also 0. Now momentum before is 0 here. We are writing momentum before firing is 0 here, and momentum after firing, momentum after firing, so we'll write this is 0 and this is m1 v1 plus m2 v2, or we can say m1 v1 is equal to minus m2 v2. m1 is the mass of the gun, which is given 10 kg. Velocity is not given here, which is v1, minus m2 is the mass of 10 bullets, that is given 0.2 kg, we have calculated here, and multiplied with v2, that is 500 meter per second. So we'll get here v1 is equal to 0.2 into 500 upon it is 10, that will be coming in meter per second. So v1 will be equal to, you can see that this 0 will be cancelled and it will come 10.0 minus it is 10.0 meter per second. So it is indicating the magnitude of the velocity of the gun is 10 meter per second, and it will be in opposite direction of the bullet, where the bullet is moving. Okay, that is in the backward direction. So you can simply say the speed is equal to 10 meter per second. Okay, now what we know, what force will be there, what force will be there on the gun, that we have to calculate. We know by Newton's second law of motion, Newton's second law of motion, that the force is equal to rate of change of momentum, rate of change of momentum. Okay, so the force F which is working on gun will be equal to rate of change of momentum, that is equal to the mass of the gun, initial velocity of the gun, and final velocity of the gun. That is F is equal to, mass is 10 kg and initial velocity is u, that is 0. The final velocity just now we have calculated, that is 10. We are just taking here the magnitude, not direction, so negative sign we are not taking here. Okay, that is minus 10 and it is equal to Newton. So F, this is 10 multiplied with minus 10, so minus 100 Newton. That means simply you can say the force which is working, suppose the bullet is there in this direction, so the force on the gun will be in the opposite direction and the magnitude of the force will be 100 Newton. This is also a doubt question in which it is given here: a bomb at rest explodes into three fragments of equal masses. Two fragments fly off at right angle to each other with velocities 9 meter per second and 12 meter per second respectively. Calculate the speed of the third fragment. So here you can see that a bomb at rest. Initially the bomb is at rest position. Suppose this is the position of the bomb and it is in rest position. And it explodes into three fragments of equal masses. Two fragments fly off at right angle. So it explodes in three fragments. Two fragments are working in this direction, that is, suppose a mass m and the velocity v1. This is the mass, another mass m and velocity v2 is working in this direction, making the 90-degree angle with each other. Okay. So we have to find out about the third fragment. What will be the speed of that third fragment and where we will locate the direction. As we know, by law of conservation of momentum, law of conservation of momentum, we know that the momentum before the phenomena and after the phenomena will be equal. That means initially the bomb is in rest position, so velocity of bomb is 0, and so that the momentum is also 0. We have already assumed that the bomb has explodes into three fragments and masses of all three fragment is m. So the total mass of the fragment is what here? Total mass of the bomb is 3m. Okay, and we'll assume here the velocity of third fragment is suppose v3. So we'll see here momentum before is 0 and after is mass of first fragment and velocity of first fragment plus mass of second fragment and velocity of second fragment plus mass of third fragment and velocity of third fragment. That means this will be the total momentum of all the three fragments. Okay, that means what you will find here, the third fragment mv3, momentum of the third fragment, that is minus mv3, is equal to mv1 mv2 here, or the mass if we are taking common, so m here is also it is common and here m is there, so m will be cancelled out. Now it will become minus v3 equal to v1 plus v2. Okay, that means what you have noticed here, that the velocity, the resultant of the velocity of the first fragment and the second fragment will give the magnitude of the velocity of the third fragment, and the direction of the velocity of third fragment will be opposite of the velocity of the resultant of the first and second fragment. We know that according to the law of parallelogram, the resultant of the two vector is given by the diagonal of that parallelogram. That means if the two vectors are represented with the two sides of a parallelogram, so the diagonal will represent the resultant of that two vectors. So here the vector v1 and v2 is represented here with this OA and OB. So the OC will represent v1 plus v2. The OC will be the resultant of v1 and v2. And just now we have calculated here the third fragment will be in the opposite direction of this, the two velocities v1 and v2. That means the third fragment can be located here with the same magnitude. If it is OC, I am just writing here OC dash, which will be equal in length of OC and but opposite in the direction. So this will locate minus v1 plus v2. This will locate here minus v1 plus v2, and that will be equal to v3, and this is equal to v3. Okay, so here the velocity of the third fragment will be found. Okay, now we will see that we have to calculate. So how we will calculate v3? That v3 will be equal to, this is v1 plus v2 we can say, or directly we can calculate v3 is equal to, because it is making 90-degree angle, so cos 90 if you are calculating, it will be equal to 0. So simply it can be given by what? v1 square plus v2 square, root of v1 square plus v2 square. So this is 9 square plus 12 square, and this is equal to 81 plus 144, and it is equal to 225. Then the 225 root is 15. So the magnitude of the velocity, or you can say simply the speed of the third fragment, is equal to 15 meter per second, and direction will be the opposite to the direction of the resultant of v1 and v2.